Last section we spent time on what theorem?
Pythagorean.
Pythagorean. Said a squared plus what?
B squared equals C squared.
Yeah, you know that. We also showed, though, that we can apply it to triangles to determine if it's an obtuse triangle or a acute triangle, given a triangle. And honestly, today, we're kind of doing the same thing, but we're going to have some shortcuts because some of the triangles that we look at are going to be, what kind of triangles? They're going to be special ones, okay? So we're going to look at two types of triangles that come up in here today, and they come up because they're half of certain shapes, right? Let me throw this up here for you real quickly. Talk to me about this. What shape is this? That's a square. So what's true about this distance right here? If this is A, what's this?
It's equal to all the other ones.
Right? So here's the deal. How about all these angles on the interior? They're all 90 degrees, right? So all these angles right here are 90-degree angles. Kids, if I cut this in half like so, what kind of angle do I get here and here if I cut this in half from the square? How much? Okay, so I'm going to show you what happens right here when we have what's called a, you ready for this? What is the relationship among the side lengths of a what? 45, 45, 90 triangle, okay? Can you remember that? That's half of a what? Half of a square, and we'll talk about that. The other one is called a what? Just want to show you where 30, 60, 90 comes from. If I go back to this page right here, you understand that the 45, 45, 90 is half of a what? Let me do this for you. Whoops. Kids, what type of triangle does it appear I have there? Equilateral. So we're assuming that all sides are what here?
Equal.
All right, so if that's true, if that's equilateral, what's that mean about all the angles inside? What are those angle measures inside? How much? So if I call this 60 degrees, I call this 60 degrees, and I call this 60 degrees. Let's just pretend that this is A, and this is A. What happens if I drop an altitude in here like so? Straight down, just like so. What kind of angles form down here?
90.
What happens to the 60 up here? It gets cut to a 30, and that's where a 30, 60, 90 comes from. What happens to this distance down here? Okay, so we're going to talk about what are the heights here. So do you understand that a 45, 45, 90 is half of a what? And a 30, 60, 90 is half of what kind of triangle? Equilateral. That's where these things are coming from today. Okay, so let me show you the relationship of stuff. This isn't going to really take us that long today. Whoops. So let me do this for you. I didn't want to do that. Here's what I want to do. Get rid of that page. So here we go, kids. The essential question today, again, is this. It says, what's the relationship among the sides of a 45, 45, 90 triangle and also a 30, 60, 90 right triangle? All right? Jobs to do today. Somebody want to read my first goal for me?
Find side lengths and special right triangles.
Okay, and the special right triangles we've kind of already identified. One's half of a square and one's half of an equilateral triangle. Okay? Then we're also going to look at some real-life problems involving special right triangles. So guys, there's going to be some things that pop up here, which you know an isosceles triangle. Okay? Isosceles triangle is a triangle where how many sides are equal? Okay, we need to remember properties of isosceles triangles. So again, understand that an isosceles triangle is a triangle that has how many equal side lengths? So maybe the left side is equal to the right side there. Okay, so just remember that. So core concept right here. I've told you when we have a core concept, things are pretty important, right?
Yep.
First core concept is the 45, 45, 90 right triangle theorem. Somebody want to read that concept for me?
Given a 45, 45, 90 triangle, the hypotenuse is 3 times as long as
Okay, and we want to make sure we read this not just as 2 times long, but this is read as the square root No, I can't even see it, but that's okay. Let me show you what they're saying. They're simply saying this, kids. If I have a 45, 45, 90 triangle, like so. This is half of a what again, kids? Okay, so let me get some different colors to this here. Give me a second. Okay, what they're saying in a 45, 45, 90 is this. If this is 45, and this is 45, they say that that's supposed to be 45 right there. This side is a length A. What's true about this length down here? It's also what? A. Okay, so what we say here, guys, is this. We say in a 45, 45, 90 triangle, the hypotenuse is the square root of 2 times long as each leg. Well, what's each leg length, kids? A. So this would be A times what? Well, it would be A times the square root of 2. All right, and I'll show you what's going on here in a second. Over here on the board, I'm going to do a quick example. You don't need to write this down, just pay attention. If I call this 6, and I call this 6 right here, and I called this x up here, would you guys agree that 6 squared plus 6 squared is equal to x squared here? Would you guys agree with that? What's 6 squared, kids? So this is 72 now. I want to show you something here, kids. You agree that x is equal to the square root of 72 here? Do you agree with that? Now let me ask you this question. Do you furthermore agree that 72 is the same as 36 times 2? So I could write the square root of 72 as the square root of 36 times the square root of 2. You guys mind that what I have from here to here is the same thing? Guys, what's the square root of 36? So the answer for x is really 6 times what? So if this was 9 right here, what would my hypotenuse be right there? Okay, are you with me on this? Okay, if you know the legs, multiply by root 2. Okay, if you know the legs, multiply by root 2. And I'll show you what happens when we don't know the legs. It's pretty simple. Okay. So let's take a look at our example below here, 45, 45, 90. How much longer is the hypotenuse than the legs in a 45, 45, 90 triangle? Square root of 2, okay? Example 1 says find the side lengths in a 45, 45, 90 triangle. Find the value of x. Write your answer in what? Well, 45, 45, 90, kids. What's true about the legs? They're the same. Anybody want to guess what the hypotenuse is without even doing any work?
11.
Not 11.
4.
How much?
4.
Say again.
Are we on A, right?
We're on A.
10.
Okay, guys, let's look at this right here. Sides are the same right up here in a 45, 45, 90, right? If that's true right here, then the hypotenuse becomes A times what?
22.
So if this is 22 and this is 22, what must this equal?
22.
Not 22, but
That's what I meant.
that's what, all right, good. So you agree 22 root 2, Gavin?
That's the number.
Are we good there?
Yeah.
Okay. All right, so let's go to the other part, part B. Instead of knowing the legs right here, they're saying the hypotenuse is what? 10 times the square root of what? 2. Well, if this is true up here, then work backwards. These are 10, aren't they? Okay, I'm going to give you some rules down here at the bottom. Okay? Rules. Gosh dang it, come on. Should probably write this down. 45, 45, 90 triangles. If you're looking for the hypotenuse, the hypotenuse is equal to a leg times the square root of 2. Okay? If you need to find the hypotenuse in a 45, 45, 90 triangle, the hypotenuse is equal to the leg length times what? Okay. But if you're looking for a leg, the leg is going to equal the hypotenuse, not times the square root of 2, but we're working backwards to find a leg. Say, divided by what? Okay, that's pretty important stuff right there. You might want to highlight this. That's pretty important stuff. So on a 45, 45, 90, how do you find hypotenuse? Leg times what? And if you're looking for the leg, it's the... Okay, now, let's move on to the next page here, kids. You ready? Okay. Second page right here. We're not talking 45, 45, 90 anymore. We're talking what? Okay. I'm going to just give you the basics of this. I'm going to draw 30, 60, 90 as best I can. I think that's pretty good. Okay, in this right here, your right angle is always where the L shape is. Does this look like the 60-degree angle or the 30-degree angle? What's this look like? Okay, what they do is this. They always call the short leg, A. All right, everything is based off of the short leg. So the short leg is which one, kids? Okay, I'm going to write some notes up here. Short leg is which variable? A. It is opposite of which angle, kids? It's opposite of 30 degrees. Okay? Now, I'm going to put in long leg here, and we're going to talk about this right here. I'm just going to tell you what it is. It's going to be very much like we did over here with the 45, 45, 90 on the left, but I'll just tell you it works, okay? Go to the hypotenuse right now. The hypotenuse, remember kids, 30, 60, 90 was half of a what? It's half of a square. Not a square, half of a equilateral triangle. We cut this in half right here. So this side, this short leg is really half of another side here, isn't it? So if this is 1A, the hypotenuse from that would have been 2A like this. The hypotenuse is always 2 times the what? If the short leg is A, the hypotenuse is how many times longer than that? 2 times longer than that. So if A was 5, what would this side be? 10. If the longest side is 50, what's this short leg? Okay. The hypotenuse is always opposite your 90-degree angle. Okay? So we know those two, but the one that's kind of special for us is the one that's the long leg. The long leg right here becomes the following. It becomes your short leg A times the square root of 3. Okay? And this is opposite of what angle, kids? Opposite of what? 60. I want to show you something. I'm going to write the notes up here. I'll show you how they get this. Make sure you have that down. Let me give you an example here, and then we'll look at some examples together. Now, this is relative to what special triangle? It's half of an equilateral, so what are the angles involved in this special triangle? 30, 60, 90. So let's talk. I'm going to draw an equilateral triangle up here as best I can. Okay, that's pretty close, isn't it? Okay, if I drop this in right here, let's pretend each side, pick a side like that, I don't care.
10.
I like 10. 10's good to work with. Okay, if I drop this in right here, 60 just got cut in half to how many degrees up here, kids? This is still what down here? And all of a sudden I have a, okay, what's this distance become right here then? If I'm looking at just the left half. Is that the short leg? It's half of the hypotenuse. So this is kind of like my A and this is like my 2A. Now kids, I'm going to show you something right here. You agree 10 is the hypotenuse in this triangle on the left? Forget this part over here now. We need to find this height right here, which is x. Do you guys agree that 5 squared plus x squared would equal 10 squared? Let me show you something. My rule right here, that long part across from 60, the longer leg should be the short leg times what?
3.
Square root of 3. What is the short leg here, kids? Okay, this should equal 5 times what? Well, 5 times square root of 3 in the end. Let me show you this right here. What's 5 squared? Right? Right? Can you think of a perfect square that divides evenly into 75? Can you think of a perfect square that would divide evenly into 75? Let me help you. How many times will 3 go into 75? But what is the square root of 25? Oh, so that means x is equal to 5 times what? Isn't that what we knew already here by that rule? So let's talk about this triangle down below. I love this. It says find the values of x and y, write your answers in simplest form. First of all, I need to ask myself the question, what kind of triangle is this? It's a right triangle, but which special one are we talking? Which special case are we dealing? Yeah, we're dealing 30, 60, 90. Kids, which side do I know up there? The 30. The 30 is like the one across from, yeah, this is like the hypotenuse. This is like the 2A. So what's that make my short leg over here? 15, right? Because that short leg, opposite, is going to be the short leg's half of the hypotenuse. That's what we said up here. I'm going to go back up top here. My short leg is A, and the hypotenuse is 2A, so isn't the short leg going to be half the hypotenuse, kids? And then the long leg is to say, well, take the short leg A times what? And that's always across from which angle? Okay, so here's my 60-degree angle. Across from 60 is A root 3. Oh, but A is what value? So how are you going to write that longest leg down there for x? 15 times what, kids? Oh my gosh. Okay. 2 rules to know. Really. 45, 45, 90. You're either multiplying by root 2 or dividing by root 2. Got a pretty good diagram up there. Can you guys read the diagram in terms of the notes there? Maybe? Okay. So let's model this. It says a warning sticker is shaped like an equilateral triangle. It says with side length of what? So we know all sides are what? It says estimate the what? Of the sticker by finding the area of the triangle to the what? Nearest 10. Okay? No problem. Can you guys help me?
Yeah.
We need to find what?
The area.
What's the area formula for any triangle? Half base times height, right? I have a question for you. What kind of triangle is this again? Do we know the base?
Yeah.
What's the base length?
4.
Do we know the height?
No.
Is there an easy way to find the height?
Yeah, 2 squared times 4 squared. We remember that answer, not the height is.
But let's make it even easier on ourselves. How about that? cut this thing in half. I'm going to cut this thing in half. You okay with that? Kids, I'm going to move this part down here, all right? If I cut this in half, what's this length down here?
2.
What's this length?
4.
Guys, what kind of triangle did I just cut in half? An equilateral, which means this angle to my point, to this point, my angle is how many degrees down here? This is, oh my gosh, 90, which makes this have to be what?
30.
Holy cow. Help me, kids. I got 4, which is double the short leg. How would you find this height, the long leg, in a 30, 60, 90?
4 times the square root.
Yes! 2 times the square root of 3. You got it, guys. Good. Well, hey, kids. Now you know the height right here is what? 2 times what? Isn't that 2 times the square root of 3? Okay, so isn't your area going to become the following? Isn't it going to become 1/2 times, what's the base length of this sign again, kids?
2.
Ah,
Oh,
4. What's the height?
4. Into the right here.
2 root of 3, right? Help me out, kids. We can leave this area in radical form if you want. What's half of 2? I'm sorry, half of 4.
2.
2 times the 2 right here would be what? This would be, area would be 4 times the square root of 3. They ask you to find it to the nearest tenth of an inch, so go ahead in your calculator, take the square root of 3, and then times that answer by 4. You'll have it. What is 4 root 3, kids?
6.928.
So nearest tenth would be 6.9, and this would be square. How did they measure the units up here? Yep. Okay, you understand that I'm saying there's this would have been a special case. If I cut this in half, this would have turned to a 30, 60, 90, which made this 2, which made that height automatically 2 times what? Very good. Okay? All right, so let's do this. Our solution right up here (6.9 square inches). Okay, we should be good with that. So let's see if we can't apply this stuff. Last page. Finding the height of a what? Okay. These things are pretty cool. Have you seen these types of trucks? They get on these ramps, they clamp them down, they just pick the whole truck right up and dump stuff. This is pretty neat stuff. It says a tipping platform is a what? Used to unload trucks. How high is the end of an 80-foot ramp when the tipping angle is? And what else? Okay, this should be so easy for us. All right. The tipping angle right here is down here. Okay. All right. This truck is sitting on a ramp that rotates around. This ramp rotates around. This hypotenuse stays how much all the time? Okay, what I want to do is draw a couple of triangles here. I want you to do the same thing. I want you to draw a triangle that looks like, oh, draw one that looks like this. Ah, shoot. Draw one that looks like this. Draw one that looks like this. Okay. Let's do the 30-degree angle one first, kids. Have a 30-degree angle, and then the other angle is going to be what? Guys agree with that? Okay. So the ramp starts flat on both of these, and the ramp starts rotating around, rotating around, rotating around. So in each of these cases, the hypotenuse is going to be how much? 80 feet, right? So I'm gonna put an 80 here for this first one. Okay, kids. When we have a 30-degree tipping angle for the truck that's 80 feet long like this, or the ramp that's 80 feet long, it wants to know how high is that up in the air. This is what we would say. It's like, well, this is part of a 30, 60, 90 triangle, right? Okay, they want to know the height. Isn't the height going to be here? Okay. Well, anybody have a guess on the first ramp that's got a tipping angle of 30 degrees? How do you get 40? Yeah, it's the short leg, isn't it? It's half the hypotenuse, isn't it? So the height in there is going to be 40. Okay? So that height would be 40 feet. So on this 80 or this 30 degree, we would say height is 40 feet. Okay? How about over here? What are you going to do to find this x? Do you know the long side or the short side? Are you finding the leg or hypotenuse in the 45, 45, 90? Finding a leg. So go back to your rules maybe on the first page. I might ask and say, what do you have to do to... Okay, take a look at it. Am I looking for a leg or hypotenuse there? Looking for a leg, right? So do I multiply by root 2 or do I divide by root 2? Yeah, we have to divide by root 2. Now, a couple things here, kids. I would say x is equal to 80 divided by the square root of 2. Okay? Now, I don't know how they want you to do this. They might ask you to leave it as a decimal, they might not. I don't know if we talked about this much, but is it a good thing to have square roots in the denominator? No, they might call this rationalizing by root 2 over root 2. To where the top would become 80 root 2. We don't like square roots in the denominator, kids. So what's the square root of 2 times the square root of 2 when I multiply both the top and the bottom by root 2? What's the square root of 2 times the square root of 2 become?
2.
Square root of 4, which is just 2, right? Would 80 over 2 reduce now, guys? So what? So I could call this 40 times the square root of 2 feet in the air. Or if you want to turn that into a decimal, somebody run it. You could just go 80 divided by root 2 right away and hit enter. I'm okay with that. You can do 40 times the square root of 2. Oh my gosh, hey, I have an idea. Take a look at that. If there's a whole number up there, how does the 40 relate to 80? It's half of it. It becomes, well, so when I divide by root 2, it's like taking the 80 and cutting it in half and then timesing by what in the end? Okay. What's 40 times square root of 2 equal? How many feet? 66.6? 56.6 feet. Does it make sense that it's higher in the air on the 45-degree tipping angle than the 30-degree tipping angle?
Yeah.
So 56.6 feet. Very good. Kids, questions? How many special triangles today? 2. One of them's 45, 45, 90. What's the other?
30, 60.
You understand the relationships in both, how the sides are related. Okay, I'm going to give you a chance to practice this real quickly on a quick quiz. I'll send out your new online page here. So what is